This recording is protected by copyright. No part may be reproduced without the prior permission of the University of South Australia.
How many of you guys are programmers here? I love telling all the programmers this system here, like when it first starts recording, the buttons are all back to front. You have to press resume to make it pause, and then it flips back to saying pause, and it's away. Someone's programmed it and never fixed it. You've got to check all that stuff, right? Okay, so this semester, I'm going to change a couple of things about database fundamentals. And the first thing I'm going to change this semester is normally we have 3 quizzes, so 3 multiple choice quizzes, okay? This semester I'm going to try and run them weekly so that everyone does them once a week. Probably going to have at least 6 or 7 of them, so I know that's not weekly because sometimes I'll just go, hey, let's not do one this week, okay? So we'll have pretty much weekly quizzes up until mid-semester break, then we'll have a break from that, and then we'll have weekly quizzes thereafter starting from like week 8 or something like that, up to week 12, okay? So there'll be a few missing. The weekly quizzes, they still count for something, okay? There should be no reason why a person has 0 next to a weekly quiz. And sometimes that 0, and it really annoys me, is the thing that makes a person pass or fail, okay? I can push someone's mark up by so much or down by so much, but if there's nothing next to their name for 6 or 8 quizzes, there's nothing I can do, okay? If you at least score 50%, that could be what gets you over the line, okay? And if I have to add another 1 mark to that to make you pass, then I'll do it. But if you're missing 6 quizzes, I can't give you 5 marks just to push you over the line, okay? So I really want you to take that seriously because I've just noticed the number of students missing those lately. Okay, so the course I've just set up by weeks. As you can see, the topics are all up there for you guys to have a look at. The pracs are ongoing. They develop every week, okay? The pracs will follow the course content because you build the database from scratch, you populate it with data, and then you write queries against that database. Okay, all the practicals are up there for you to have a look at. So if you want to race ahead, you actually can. All the tutors that you guys have done these pracs previously, okay? So they know what's in there. They'll be able to answer any questions if you do race ahead. It's not a problem. Is there any questions about that? So weekly quizzes, they do count for something. Make sure you attempt them. I'll probably have a minimum of, well, I'll usually say 2 or 3 attempts with the highest mark counts, okay? So there should be no zeros. I won't chase you if you do get a 0, but that's up to you. Okay, so I'll leave that. Is anyone planning on downloading their own version of SQL Server, which is the program we're going to use this semester? Yeah? Okay. Do that sooner than later. I think, from memory, the practicals really start using that by week 4 in detail. Okay? So you've got a couple of weeks' grace to try and solve any problems. If you do have problems, I can look at some laptops and try to solve it. It gets quite messy sometimes, but we usually get a workaround. I recommend you do that soon. The instructions are there up on the course website. Usual Microsoft stuff, they make it really complex. Okay, you've got 50 choices, you've got to choose the right 2. And yeah, you love Microsoft, right? Okay, the examples are there for you guys to have a look at. There's the list of options for 64 and 32-bit. Does it matter if you pick the wrong one for 64-bit? Probably not, because there's different server versions that have different additions on them, okay? And they'll still work, it's just that it's a bigger download and a bit of a waste, something like that. It's probably the way to think about it. Make sure you download SQL Server 2014, because that's what they've installed at the computers at uni. I've checked that download, I've created a database and tested it on the uni computers, and it is compatible this semester, okay? ITS had this great idea to half update the computers last semester, and we had all sorts of incompatibility problems, okay? You can't create a database on a newer server and expect to mount it on something that's old. It doesn't work. Any questions about that? So a few of you guys are going to do that. Do it soon. If you have problems, post it on the forum, and a few of us will try and help you debug it, okay? As a last resort, I might have to look at your computer, but I can't guarantee anything either. Sorry? Yeah. Okay. So, after all that, I still haven't said who I am. I'm Doug, okay? Crazy, isn't it? Yeah. Doug, who has a Master of IT degree, okay? So I was a research scientist to begin with, and I'm now here teaching databases, even though I never used a database during my research degree. It's just one of those things that you wish you had learnt about, but it's too late now, okay? I've moved on since then. Are you the same? Yeah, okay. So we used Excel spreadsheets. We got into a huge mess. Didn't have a database, didn't know what it was back then. Had I known, I would have been so much better at what I was doing, but it's too late. Okay, so that's what I'm going to teach you this semester. So some of the skills I give you or some of the things I tell you will be based on my life experiences as well, okay? So I'm a doctor of cardiac physiology, okay? I dealt with, ECGs and mostly, I guess, ion channels and all that sort of stuff. Lots of numerical data, I guess you would say, frequencies, all that sort of stuff. So it's a different type of data set. And so that's where some of my experiences come from. What are you going to learn here? Well, obviously it's going to be about databases, but relational databases in particular. Okay, so a relational database is a type of database that you guys are already familiar with, even if you don't realise it. There are other databases that you'll learn about in enterprise databases next year. Okay, they're the harder ones, but they're also the newer ones that are more scalable. Okay, we're going to do SQL, so structured query language. There's a huge focus on it. Okay, probably 80% of the course is SQL, I'd have to say. And then applying your skills in those areas. Okay, so your assignment's going to be to design a database, and another assignment's going to be writing queries to extract information from a database, that sort of thing. Prerequisites, you guys should have done problem-solving skills, so problem-solving and programming, I think it is, okay? It's really important that you have done that. Does anyone know what a data type is? Yeah, okay. Data types are really important in this sort of stuff. The other thing I'll tend to lean towards is sometimes we'll make decisions based on programming experience as well, okay? It's really annoying, but some of the things we do here will be based on programming, just to warn you. Okay, I say there's no recommended textbook. I don't like textbooks. I suppose for this course it doesn't matter because relational databases has been around since like the 70s, right? But when you come to web stuff, I do teach with web as well, okay? And I wrote content that was out of date 8 weeks after we started and it stopped working. So textbooks, I don't recommend them because you can find everything on the web. I'll give you links as well. And personally, I reckon you're better off saving your $120. Okay? I've seen some pretty good $40 SQL books, handbooks. So I'd rather go for one of those if you had it. So no actual textbook, but if you want to buy it, there is one recommended for next year, okay, for enterprise database, and you can go get that if you want. The version I had, the index was all over the place, so I still didn't use it. I'm sure you can find it online as well, right? Okay. Course content, the readings. I've got some notes up there. They're nothing spectacular, right? They're just things that I slapped together when I was creating content, but there's more than enough info in those, okay, to do everything. Those notes I even leave up during the exam, okay? Yeah, it's crazy. And still people fail, okay? Yeah. Okay, so you've got the readings there, you've got some links. If people find other useful links, email them to me and I'll post them up on the course website, okay? Or put them on the forum. I'm all for shared learning, okay? I don't want you guys spending money on textbooks that are no good in a year's time. It's not worth it. You've got the assignments. I actually don't release the answers to the assignments, but I have got some previous year's stuff up there, okay, that you guys can troll through if you want. You've got the practicals. Yeah, you get the answers to the practicals and the tutorials as well. And where a query's got like 5 different alternative answers, they'll all be in there. And if you've got a different one again that's still right, then give it to me and I'll throw it in there as well, okay? So you can see the different ways of doing the same thing. Obviously, they're not all optimal, but they work, okay? And when you come to programming, you'll realise that sometimes the less optimal way might be the most easiest to read or solve straight away. And when you've got a client breathing down your neck, you just want to get it out, okay? You can come back and optimise it later. Support. Okay, even though I said I'm not taking the pracs this semester really, or the tutorials, you guys can still come to me, okay? I'll put my room number and everything up on the course forum with some times that you can come and see me. The rule of thumb is if my door's open, just come in, okay? It's not uncommon to find like 4 or 5 people in my room, well, not my room, my office chatting, okay? It's a bit of an open slather thing. It keeps everyone happy, and I guess it's more social, okay? There is 3 tutors. Nathan Lakes is taking predominantly most of the pracs and tutes this semester. Nathan's really good with numbers, okay? He's a bookkeeper in the past, and he's got his IT degree, and he's got some good companies chasing after him at the moment. I can tell you that right now. You can ask him anything about the databases, and he'll be able to help you with it, okay? Students loved him last 2 semesters, okay? So if you've got Nathan, use him to your advantage, because he's really good with those numbers and managing queries. If you want to know a bit about NoSQL, then ask Nathan as well, okay, because he's done some research on it. Michael B. Wong, okay, he's doing his PhD in sort of data mining type stuff, okay? Again, go for it, just ask him all those sorts of things. And he's also fun to be around. They're all fun to be around, okay? Christian's a bit of a soccer fan. I'm not sure what his PhD is, I should know it, okay? He's more of a programmer, but also database as well, okay? So you've got a range of people there. You should get along with them all really well, okay? If you don't, if you have some problems, just email me and we'll sort it out. It's no problem at all. Okay, assessment. So the assignments are worth 40%, okay? Assignments, so the first assignment, it says it's a design assignment up to 2,000 words. Less words is better, okay? I hate reading. When I say design, it's like drawing a diagram, okay? And if you make some dodgy decisions, then yeah, you probably need some dot points there, okay? That's the writing. Design is drawing a diagram, writing out some table layouts, and then some table creation statements, okay? So there's actually not much writing in it. As I said, anything that you think is debatable, that's where the writing comes in. So don't think you have to write 2,000 words, because I don't want to read it, and I bet the other guys don't either. Okay, so I'm not forcing you to write anything on that, just it's an upper limit. Assignment 2, there is no technical writing at all, it's just writing queries, okay? So there's no debate about it, it's just writing a few queries, so if you can program, you can do that. The continuous assessment, which I said now will be nearly weekly, is just multiple choice quizzes, okay? Nothing spectacular. It's A, B, C or D, pick the right answer and off you go. I usually release the marks after everyone's finished the quiz, okay? So that one, the weekly quizzes, so I'll usually release it like on, well, it's a bit odd because we're on a Friday, right? I'll release it probably on the Friday or on the weekend, and then you'll have 2 weeks to finish that one quiz, okay? So you do the content today, and last week's content will be the quiz that follows this lecture. I think that's probably fair enough, yeah? So 2 weeks to do it, so there's no reason to miss it. The exam is fully practical, okay? We do it in the computer pools here at Mawson Lakes. And it's 3 hours, it's online, doing everything you do in tutes and in the pracs. Okay? In fact, the last section of the exam is almost, well, it's the same as assignment 2, okay? It's the same sorts of queries. So, everything. We'll see how we go with that. Plagiarism, a few people have been done for that. I hate talking about this stuff, okay? I have not actually busted people for plagiarism during the course, but oddly enough, during the practical exam was the crazy thing, okay? Make sure when you do assignments, I don't mind if you discuss them with each other, but don't copy each other, because when it comes to programming, it's really easy to pick it, okay? And the tutors pick up, well, obviously Michael B. Wong being a data analyst picks up on this stuff really quick, okay? So be careful. Work on it individually. If you've got problems, you can come to one of us tutors and we'll help you, rather than sharing answers, okay? Just be careful about that. Okay, so today we're just going to do a quick outline of everything, which will scare some people. If you drop out, okay, that's fine. And then you'll have to come back next semester and do it anyway. And next semester is a smaller group. Semester 1's always a small group, okay, 60 students. We've got the relational model, which is the way that we store our data in our database, okay? It's through relationships between rows of data. We talk about a bit of conceptual and logical data modelling, so drawing some diagrams of what our database should look like before we implement it. Table creation and query writing, well, that's in a couple of weeks' time. Okay, there's a fair bit on that. As I said, it's the main emphasis because it's the skills that you really need. All things SQL, so it's all to do with that. Okay, the course is definitely technical. In fact, today's like listing off a whole bunch of keywords that you guys have to remember. Stuff that you'll see on the internet. I don't put every keyword in there. Okay, I noticed the slides today don't even have super key in there. Last time, when was the last time you talked about a super key? Never. Yeah, neither did I. Okay, and I just mentioned it, but you'll read about it somewhere for some strange reason. Keywords. I went through these slides, and every SQL example, because the program that we use called Management Studio highlights keywords, I've actually gone and made sure every slide highlights those keywords as well. Okay, so keywords are highlighted in blue, just like in Management Studio, because I think it helps you guys remember what they are. And some of them just come back time and time again, and it makes it a little bit easier. The time commitment that you guys have to spend, well, it's heaps. Okay. If you're not doing at least 4 hours a week of study, then you might run into trouble a little bit later on. Okay, so 4 hours seems a lot, but when you consider the amount of stuff we cover, you'll probably need it. Okay, this one burnt me last semester. Okay, SQL Server 2014, the version that I've put up on the course website is installed only on the computers at Mawson Lakes, not at City East or City West. Okay, so don't go there expecting to find it. As I said, if you're going to install it on your own computer, do it soon. One of the things I also recommend you do is under the properties, so what is it? Local services. You can find SQL Server under all your local services and put it on delayed start. Okay, because you don't use it all that often on your computer other than the 4 hours a week you're doing study. You don't want it to be booting up every time you load your laptop. Okay, so put it on delayed start. How many Mac users do we have? 1, 2. Okay, you can still do it, but make sure you mount everything not on the shared folder. Okay, because the database is locked to a single, well, DBMS user. Okay, so one user. If you put it on the shared folder, it won't work. Okay, so is there any questions about that? No questions at all? Okay. What have we got here? 0 questions. We're all happy? Weekly quizzes, which actually sound bad, but it is a lot better than doing them in a huge half-hour sit or something like that. Okay. I'll keep them to like 5 minutes tops. Okay. I might even just do 5 questions, 5 minutes, something like that. Keep them short. Okay, so what is a database? Well, you guys already know what a database is, probably. It's just a collection of data. It might be in a file, it might be in a book, it could be anything, right? You guys all have, well, everyone has databases these days because they're on your phones. Your iTunes account has a database of songs that you like. If you pirate stuff, how many people pirate stuff? Yeah. Okay, we've all got a database of pirated stuff, I'm sure. What do we use? Is ISO Hunt still around? Or is that gone? It's gone, damn. That's the one I used to use, yeah. Oh well. Okay, I haven't done it for ages, so I'm a good boy. Because Google does it for me now, anyway. Okay, so pirating, yep, everything there. Okay, so it's a collection of some sort of information, okay, data, and it doesn't matter on the format, it's just a collection of data. And the data reflects some sort of real world or theoretical object, okay, so it might be textbooks, okay, you can have a database of textbooks, you can have a database of music, so something that you can't actually hold, it's theoretical, kind of, all that sort of thing, okay. Copyright, you can have a database of copyrights that you guys have ignored. Okay, that would be theoretical. Okay. It's okay, and a database has, well, it should be managed by a database management system, okay? Because as you add more stuff to your database, you need to be able to track what's in there so that you don't download it again and waste your download. Okay, and that's what a database management system is. That might be a computer with a bit of software on it. It might be, well, I've got a video here of a catalogue card. Who's used catalogue cards before? We have to have, right? Yeah. Who's used, yeah, you too. Okay. Catalogue cards, who knows what a catalogue card is? Yep. Okay, there's an Indonesian university that still uses them in 2013, I saw. Who knows what an LP record is? This is freaking me out, yeah. Okay. I'm aging people just by putting up their hands, I reckon. Yeah. Who knows what a cassette tape is? Yeah, okay. Yeah, who knows what a cylinder is? You're not 100 years old, man. Okay. Okay, so I've got a little example here. I don't know if it's going to work. We'll find out if it does. Let's have a find out. I can't even find the controls on there anymore. It's all changed, okay? Someone who's programming this stuff does not know how to program a user interface. Who's doing user interface in the future? Make sure you check out this thing down the front and learn what not to do, okay? Okay. And it doesn't even run on there. Okay, we'll skip it. Because you guys can't hear that, can you? You can? Let's see. This is like old school, right? Okay. Let's see what we can do here. It used to work through HDMI, because audio is part of HDMI. It's been around for ages, right? And it's missing this semester, so I have no idea what's going on. One of the interesting things is the guy that does the audio and IT here likes analog stuff.
Is stored the sum of man's wisdom. Close to 50 centuries of human thinking and experience. Almost all of recorded history lies at hand in the library's nearly 4 million volumes, inscribed in 3,000 languages and dialects. Through the entrance to this palace of learning pass more than 2 million persons a year. It is the greatest and most used library in the world. Although primarily devoted to scholarly purposes, it is an indispensable research arm of government and industry in peace and war. Heir to the literary treasures of the past, the library offers them free to all. Upwards of 8,000 persons a day come to the New York Public Library. Each has a question. The answer is somewhere in the library's millions of books and manuscripts. The search begins. It starts in the catalog room, where some 7 million index cards fill the row on row of drawers that line the walls. Books are listed in 3 ways, by author, subject, and title. Magazine articles are cataloged by subject. The drawers may be taken to tables so that call slips can be filled out for the books wanted. The card index is the key to the library's usefulness. Books that cannot be found are useless. Call slips, when presented, are dispatched by pneumatic tubes to the stacks, where a library employee begins the search. 1 book out of nearly 4 million. It seems like looking for a needle in a haystack, but it really is not, for although the library has some 80 miles of shelves, careful cataloging, like an electronic eye, directs the library worker straight to the desired book. Elevators transport the books to the main reading room, riding the lift and passing from floor to floor. Here is a look at the library's repository of knowledge. 7 floors of stacks, recording man's aspirations and achievements in every field of human endeavor. Pages from the past and the present join together to hasten man's progress into the future. When requested books reach the main reading room, they are taken to the delivery desk. Each order has been numbered. A switch is thrown, and the indicator flashes the number for the waiting reader. Seven minutes after submitting the call slip, he claims his book. Some 20,000 similar requests are handled in a week. Although the books are not allowed out of the main reading room, there is no time limit on their use. Nearly 800 persons can be seated in the reading room, which covers half an acre of floor space. Here, only half of the room is shown.
Okay, so that's a relational database, right? What are some of the problems with that relational database? Sorry, guys. So speed. Sorry? Time consuming. Yeah, how many people are employed to go grab 1 book? Well, looked like 4, I think it was. Okay. Okay, so a relational database, it may be inefficient, but it also tracks things, okay? So if you look at the old forms of storage, I mean, it's still a relational database. It worked for a good 80 plus years, okay, before it got moved over. Some places still use that system, they have to. In fact, why would you still use that system of catalogue cards today? I can tell you, Flinders University School of Music was still using it up until maybe 10 years ago, maybe 5. Possibly still using it today, I haven't gone back and seen. Why would you still use catalogue cards if it's so slow and not all recorded electronically yet? You have to pay someone to do it and they have to get it right, because if they get it wrong, you lose the book, right? Even the video said it. Okay, it costs money to transcribe from catalogue cards into electronic forms these days. Okay, so we had a few things. It was definitely slow. In fact, 7 minutes. When was the last time you guys did a Google search that took 7 minutes? I don't think anything's ever taken that long. Maybe the internet went down. Okay, there's a limit on the physical size. Okay, that library is huge, but you guys probably have a library that's bigger on your laptop. Okay, quite easily. You consider all the files that Microsoft has on there just to make their things run. Easily beat it. Okay, limited multi-access. Okay, you borrow that book and you're sitting in that room of 2,000 other people and someone else wants it, good luck to them. Okay, you can't share that resource at all. Okay, the limited search methods. Okay, the old catalogue cards, you had 3 choices, was pretty much the go. Okay, so I mean, physical is not bad. It's just that as we said, it's labour intensive to manage these things. We still have indexes today. That's what a catalogue card is. It's just that our indexes aren't limited just to title, author and subject. Okay. What happens if you have multiple indexes as well? Okay. What happens if a card goes missing from one and not the others? If you remove a book from the library and you have 5 indexes so that 5 people could share it at the same time, you have to worry about all those sorts of things. Okay. So a modern DBMS manages all these sorts of little issues for us. The maintenance. Okay. As they said, if a card goes missing, then the book's as good as dead. Okay? Are you actually going to pay someone annually to go through 8 million books and make sure that all the cards are in place? Probably not. I think it would just go missing. You would get over it, I think. Okay, so, and what else? The slow turnaround. Easy. Okay, so physical storage has its problems. We still have a management system in place. It's just that these days we're moving that whole system into an electronic status, and we still have that management system to process it, okay? The main thing here is that we have those multiple indexes that have to be maintained, okay? And a database management system does that maintenance for us, okay? So that's the software we're going to be using this semester. It's going to do all the, well, we write queries to communicate with it. It goes off and then manages the records, goes through them, pulls back what we want, and in under 7 minutes for sure. Okay. There's other problems with those old traditional systems. They still exist today, but in different formats, okay? So we have what happens if an item is deleted in one index, but not in the others, okay? So someone flogs a card from one index. How do you know if the item's not in the library? You have to go check all 3 other indexes, something like that. It's kind of crazy. You can imagine kids would do that for a joke today, right? I probably would myself, okay? An item is entered into the index, but not the others, okay? Librarian staff, if they want to sabotage the system, pretty easy. What else? Incorrectly entered. I got burnt on that the other day. Has anyone done AEC training and helped out with the election and stuff? No one? You guys should do it, it's easy money. This guy here left one number off of his account number, and they just went and added a 0 at the front, and so my payment went off to someone else or something, okay? It's heaps easier to do, okay? So incorrect data happens all the time. If you've got something that manages and checks all these sorts of things, because you can put checks in place, then you can avoid those issues. A simple check for mine would have been for the system to make sure that I had 9 digits and not 8. A programmer decided to put a 0 in front and make it 9, okay? They could have rejected it at the very start. What if the catalogue card is misplaced? Well, if something goes missing from the index, as we said, then that's kind of it. You can't get a handle to that record anymore. The main thing with the physical limitations is, well, how many books can you query? Okay, you guys can do queries way faster on your laptop than you can do through that New York library, for sure. Okay, and we said you already have more records as well. So, today we still have our relational databases. in a whole series of things, okay? I can tell you the state government does a lot of their database management for, I guess, small tasks and stuff in Excel spreadsheets. You might ask yourself why. Well, it's probably because the people that have been employed that are still there, that's what they knew how to use 10 years ago, and so that's what they've done, okay? They do have databases like SQL Server as well, but not everyone knows how to use them, and so quite often what happens, certainly with my sister, she asks for data, someone writes a query and then exports it out to an Excel spreadsheet. Can anyone imagine what's the problem with that? You pull data out, put it into a spreadsheet, you start mangling it, and then you want to send it back. But how many people have had a copy and mangled that as well? Okay, so this crazy stuff still goes on these days. So if you know a bit of SQL query writing procedures, right, you guys can do things for the government that a lot of employees can't. Okay, my sister would love to know how to do SQL. I've just never taught it to her. Okay, is that lazy? It's 4 hours a week. I should do that. Hey. Okay, so it doesn't have to be in an Excel spreadsheet, it can be text files, anything you want. In fact, if you go to the data sets online from the government, you can download CSV files. Who knows what a CSV file is? Yeah, comma separated values, yeah. Okay, that's the other common format. They all have drawbacks because they're a bit slow, okay. They're linear searches if you want to go searching through those sorts of things, okay. So if you've got an Excel spreadsheet, what's the maximum limit of rows on an Excel these days?
What version?
I have no idea, man. 2013. 50,000?
No, I think 2007 and 2010, 65,000.
65,000? Yeah.
13 has doubled it.
And how long would it take to do a VLOOKUP and stuff? You don't want to know? It just crashed, does it?
No, it doesn't.
Okay. Come on, it's Microsoft, it must. Yeah, it stops responding for 10 minutes, yeah, and locks the PC. I haven't tried it, okay? But that's the stuff I used to do, and it didn't really work that well for me. In fact, I used to go onto the Google, well, it wasn't Google back then, I can't remember what it was, because we had Netscape and stuff, and I used to post on a forum and I get other people to do it for me. But, don't do that, remember, plagiarism, okay. So we have slow retrieval, all that sort of stuff going on here, okay? So a DBMS, in the sense, is still there, it's just that how well it operates depends on how the data is stored underneath it. Okay, that's the whole point of this. And we're using a relational database, and it's built in a different way using files on a hard drive that are a lot easier to manage. Relational databases have had a bit of a beating over the last probably 5 years because we've got the NoSQL and stuff coming up, but they're still really important for small to medium enterprise, okay? If you want to know how hard it is to establish a NoSQL database, so one of the new ones, just go ask Nathan, because that was his project, okay? He didn't have a great time for the first few weeks trying to get it working. Whereas you can download this and it'll be working within minutes. You can start using it, you can build interfaces to it using Microsoft Access, and you can have a business up and running by the end of the week. Easy. Okay, the NoSQL, all that sort of stuff, well, I guess we were talking about the state library just before. You consider how much data has been growing over the last even last 5 years, okay? It's not doubling, it's getting huge. I don't even know what to say anymore, okay? So they're saying here roughly, let's say a textbook is 1 megabyte of information, okay? If you have 1,000 of those, what's 1,000 megabytes? Sorry guys? A gigabyte? Yeah, okay. And if you have 1,000 of those, we get a tetrabyte. And if we consider what the New York State Library had, well, most of you guys probably have what do you guys have, a terabyte hard drive in your laptops now? I don't, I'm not that lucky, but still, okay. So most of you guys have more than what the State Library could have held back then in the 40s, easy. And now you've got petabytes and all sorts of things going on. Where do you think that data's coming from? Instagram, probably. Facebook, yeah, they're collecting everything. They love to know about you, okay? And no one deletes anything, right? It just keeps adding and adding and adding. And that's kind of where the relational database kind of starts to slow down and drop off, okay? It has a limit. Everything has a limit. This one, did you know this? Did you know data is still stored on tape, okay? Back in 2011, I think Google had to back up a whole bunch of people's accounts from tape because they lost some data. It happens. I didn't know this, okay? I didn't know that tape was probably still the cheapest and most efficient form of storing data, okay? Crazy? Tapes can hold up to 6 terabytes, which is why they're popular, and those terabytes are cheaper than a standard hard drive. What else is there? It's lower error rates, lasts longer. Something else I didn't realise was that it's also less prone to viruses because you have to scan the whole tape, and it takes you about an hour to go through a terabyte. Okay, so a virus can't move across your tape so quickly, especially considering it's a physical medium that has to be read and written to. Okay, so there's a few advantages, and that's why they still use them. Best one I remember was my father used to work at ETSA, and they had those massive, I guess they were 30-inch floppy disks. Do you remember those? You do? Oh, wow, okay. No, I'm not aging. Oh, this was ETSA down on Green Hill Road before it became a apartment building. So they had all their data on these massive 30-inch disks, floppy disks. Sorry you guys missed them, it was great. Okay, and they kept the data and someone threw out all the hard drives. Okay, how do you read a 30-inch floppy disk if you throw out all the hard drives? No one has them anymore. Okay, that's why tapes are good as well, because tapes, they're easy to read. Like you can get a tape, quarter-inch tape head, and just run the tape past it, you can still read it. Okay, it's possible. If you get a 30-inch disk that's in some sort of weird format, you throw out the machine, good luck to you. Okay, oddly enough, we keep all this data and maybe 10–20% of it's used. Okay, why would we keep all this data and not use it? For when we do need it. 40,000 people at Google wouldn't have been happy if they lost their stuff forever. What other things? Future analytics, yes. Legislative requirements, okay, that's everything there. Okay, so a bit of data mining for selling off in the future, whatever it is that you're doing, or maybe someone's done something dodgy, you have to go back 10 years to find out when it first started, and you go back, troll through the data, and if you can't store terabytes, then you're in trouble, for sure. Okay, why do we store data and not information? Well, as I said, data was like numbers and stuff, so frequencies and heart rates or whatever it is. Why do I not store information? Why do I not store the mouse was, having a heart attack and the beats per minute was 36 and something else as a single line record? Takes longer to search. Takes up more space, has limited meaning because it's already got a context built into it. If I want to do a quick search and find how many mice had the same heart rate and weren't in that sort of trouble, that sort of thing, okay? That depends what I'm looking for, okay? So data is basically just simple facts. So frequency numbers, heart rates, whatever it is, with no meaning attached to them other than it's a heart rate, it's a frequency. That's it, okay? Because it's a simple fact, it means you can add multiple simple facts together to get a different picture, so a different context, and that means your simple data is reusable for other things, okay? And that's where the data mining comes into it as well, okay? Because you might record all these transactions individually, they don't mean too much, but when you look at patterns of them, that has a different meaning, and so you're pulling out different information. That makes sense, okay? So data means we can ask different questions of that data by pulling it out using some queries, adding those bits of data together, so you might be adding numbers or whatever it is to answer a different question, and you get a different meaning from the same data set, okay? Like recording date of birth. You might just be recording a whole bunch of date of births, but from that you can deduce someone's age, which has a different context and all sorts of things, okay? That's an example there. So simple reuse is the main point. And that goes back to what you guys were saying just before. That turned out to be a fallacy, I think, didn't it? The Target thing, where they knew about the daughter's pregnancy before the parents. They were saying they did some data mining. They saw that this person was buying certain things from Target and they predicted that she was probably pregnant, okay? But it can happen. So trends from the data, you can ask those questions based on the data itself and pull out certain trend information that otherwise we wouldn't know about, okay? And that's another reason why we like to keep lots of data, because some things don't develop for years. If you throw it away every 2 years, then you can't go look for that. So is everyone okay with that? So we're looking at simple data, which is simple facts. You can assemble them together using some queries to answer questions that maybe we hadn't thought of previously. That's the whole point here. Okay. We talk about data models. A relational model is a data model. It's a restrictive one, that's for sure. Okay, it's been around since the 70s, and it stores our data, so our numbers and whatever, in a structured model on the hard drive, I guess you could say, in some way. It's a logical structure. It's hard to describe it to you guys. I think you'll go into it more next semester. When we say structured, what do you think it means by structured data? Sorry? It's not messy, okay? It's got a real shape to it, okay? You're saying this is what I've recorded, this is the layout that it's been recorded in. You'd be looking at the data and saying, okay, a date of a birth is stored as a date. You might have, your street numbers stored as integers, which would be bad. All sorts of things. You shouldn't record account numbers as integers. We'll come back to that again as well in future weeks. Yeah, sorted, ordered, all sorts of things, okay? It's really restrictive about how things are done. You try to put something in there that doesn't fit, it doesn't go in, okay? So if you try to put a, 14th of July 2008 instead of the date as a number, it'll reject it, okay? It's structured. It's a fixed structure that only accepts data in a certain format, otherwise it's rejected. It has problems for us, which is why people are moving away from it, because it means you think about modern business, everyone's changing all the time, okay? You get, how many people actually work here? Do you work? You have, does anyone do like their own sort of business thing where you talk to clients and sort of stuff like that? I hate it, but clients are always changing their minds, okay? A structured database, when you want to go and add a column to it, it becomes a real dilemma, okay? Because it changes the underlying data and the relationships, and it just doesn't handle it all that well, okay? So structured data, you come up with a design, you try and stay with it. If you don't, then it can introduce problems later on, okay? It's good for up to about 10 to 100 terabytes. It's debatable. Same problem with the New York Library. The bigger it gets, the slower it gets, okay? It scales up, but it doesn't scale out. When we say it scales up, it means if your data gets bigger, you have to throw more money at the server. So more CPU cores, more RAM, bigger hard drives, and all of that has a limit. Okay, so scales up has a limit. Okay, there are alternatives. Some of them old, some of them new. So objects, XML, hierarchical, network, database models, they all exist. Go have a look at them on Wikipedia if you want. The new one, which is the unstructured or key value pairs. So dictionaries, okay, JSON. We do a bit of that in web as well, and you do it in database enterprise, okay? They're non-structured. If you have to change the structure, you just add to it and it doesn't care, okay? There are obviously drawbacks of that sort of thing, but you'll discuss those next year. So everything's got its drawbacks. Okay, doesn't matter what we choose. Our models have to be talked to through our relational database. Our database management system, okay, we have to talk to those models some way. That database management system does that for us. And we have to talk to our database management system using some sort of common language, and that is structured query language, so SQL, okay? Not standard query language, it's not standard at all. Microsoft has all its own little glory things in there. Every language has their own glory things, okay? So it's structured query language. It's like a declarative language. What does that mean if we say a declarative programming language? God, that's testing your first semester. Who's scrapped first semester from memory? No? Okay, it's sort of like black box programming. You use a few keywords and you say, this is what I want, and the DBMS works out how to extract it, okay? So that's what SQL is. It works out how to do it, goes off and does it, and then just brings you back the answer. You just have to know how to work it. Okay, so keywords in a logical pattern to answer some queries, and that's how we talk to our DBMS. That's all we're going to do this semester. It's high-level language, simple to understand, common patterns. Once you get used to the patterns, it's really easy. Okay, and the database management system takes these SQL queries. And I hate saying that because SQL has query in it. Okay, and it acts those against your database model, which is going to be our relational database model, gets the data, brings it back, assembles it in a way that answers your question. Okay. So the different relational database models we have out here, we have SQLite, MySQL. Who uses MySQL? There has to be some MySQL users here, right? No one? or Apple Mac users use it by default. Okay. SQL Express, which is what we're going to use because it's free. And then we have PostgreSQL, which is probably the less popular one at the moment, but it's good for geographical databases. Is anyone doing like geography type studies here? No? No one this semester? Okay, because that's the database they use. Microsoft SQL Express is just a cutback version of their full version. Okay, we used to use Oracle. I think you get to use it next semester in enterprise databases. It's just that we had a web interface that wasn't that fun to interact with. Okay, so we're using Express this semester. Okay, so as we said, the DBMS is just there to manage your data and make sure it's safe and well kept. Okay, so it ensures that your data is persistent. So if you go and change something, it makes sure that the change happens and that it does happen and that it's finalized. Okay, persistent. It makes sure that your data is reliable. Okay, if you go and make a transaction, so you're putting money into someone's account and the power goes off, the database management system, when it comes back on, checks a whole bunch of things and decides whether the money was there or it wasn't there, and then rolls back what happened. Okay, it's about making sure it's reliable and it does go through. It's also about managing efficiency. We don't want any 7-minute queries. It does happen. If you get a 7-minute query in a practical, then you've made a mistake. Okay, most of them will execute in under 1 second unless you get it wrong. Okay, so moving on to this. So here's our DBMS. Well, it's missing at the moment. Our DBMS, as we said, is going to communicate with us through SQL. And it doesn't just communicate with us through SQL, it communicates with websites or web applications, desktop applications, and then obviously our Management Studio user interface as well that we're going to type into. Okay, you write these queries that you type, go into the DBMS, it looks at it, it parses it, checks it for mistakes, checks it for operators. Have you done operators and stuff in that first year course? I keep forgetting what it's called. Not programming fundamentals. I've forgotten already. Problem solving and programming. Do you do operators in that? Yep, so bod maths type stuff. Okay, so it goes through, checks your query, sees what's in there, makes some decisions about what should be done first and what should be done last. Okay, it optimizes the query. Okay, it can be done in a number of ways. It comes up with not just one way of executing your query, but multiple ways. Okay, there's multiple plans get created, and it goes, okay, this plan is probably the fastest, and therefore that's the plan it goes and uses and runs against your data. Okay, so it doesn't come up with one plan; it comes up with a few. How many? Who knows? Okay, and one of those plans gets grabbed, used to extract the data, in the hope that it comes back faster than if it just went for the first choice. Okay. On top of that, your database management system has a whole bunch of other tasks, not just reading your SQL queries and interpreting what it is you want to do with your data. Okay, there's a transaction manager. So, as I said, if something goes wrong, the power goes off, it decides whether a process went through or it didn't, and what happens when the power comes back on. Okay, so that's called a transaction. We don't really do those this semester. I think you do it next semester. Okay, so was the number updated? If it wasn't, do I roll back that transaction and leave it unchanged? Or do I process the transaction and pass the changes through? It will never leave things in an unsecure state. Okay, it either did or it didn't happen. Transactional. Okay, we have a lock manager. What happens if 5 people are trying to access the same record and one of them's updating it or something like that? Do you allow all 5 people to read the record? Do you allow 4 people to read the record and fail the person that's updating it? Or do you go the other way? Okay? You can lock records to stop other people from viewing them as well. And that makes it multi-user friendly, kind of. If you think about it, you don't want to be locked out really, but it does happen. Okay? We have the recovery manager. Okay, so it keeps logs of everything that you do. So if you update tables and things, it keeps a log of all those changes so that if something does happen, it can go to the log and reinstate all those changes and restore it back to some sort of reliable state, I guess you could say. Okay, and then the last thing, I don't really mention this stuff after this week, okay? You can look it up. It's kind of interesting, but it's really technical. We have a system catalogue, okay? You might be asking, well, how does the database know which of those execution plans to pick, okay? Well, it keeps statistics on which indexes to use and what what things are faster when it executes them, okay? It stores all of that in the database as well, along with your data, okay? So the system catalog has a whole bunch of information in there about your tables, the attribute names, the types of data that you're using, the indexes that you might have, so lookup indexes, which ones are fast and for what queries, that sort of stuff. Okay, and also along the side that we have your index files. Okay, so are you looking up by first name, last name, subject, title, whatever it is, and also your data files. Okay, they're two different structures. You have your data and you have your indexes. They're still kind of like tables, but they're just ones you don't control. Okay, any questions about that? So there's heaps in a DBMS. That's just the real basics of it. Okay, so why do we want to do this? Well, as I said, small to medium enterprise really does still use relational databases. It's probably still the number one thing I'd have to say, other than Microsoft Access and Excel spreadsheets. The number of jobs for students pulling things out of an Excel spreadsheet and putting it into a database now is actually on the rise, okay? Because Excel spreadsheets, as we said, only last so long. And certainly now that you've got people being disseminated around the state and working on the same data set using Excel spreadsheets, it just doesn't work, okay? So we need the DBMS to help us with that sort of setup. And we can do those things remotely. The DBMS manages those transactional problems that we might have. Okay, we use the skills that you take from this semester, we apply them to web development next semester as well, okay? In fact, when you guys go on to do ICT projects in third or fourth year, half the students end up working on some sort of database, okay? So you'll need these skills later on. You can't escape it. In fact, they're sought after skills, I would have to say, yeah, right? If you have database skills, you'll get a job somewhere for sure, okay? I'll leave it at that. So we'll have a short break and then we'll flick through all the key terms that I need you guys to remember for the rest of the semester. I'll try and make it as fun as possible, okay? It's just like reading a dictionary, I guess. Okay, guys. So, for the next couple of weeks, well, probably not even that actually, maybe just 1 week, okay? We're going to be talking about conceptual models, okay? So we said we know we're working with a structured database, and a structured database doesn't like changes, so we come up with a conceptual model. We make sure it ticks all the boxes, that the client's happy with it, and that it's covering everything that they want to record, because we know if we have to come back and change it, it's a bit of a pig, okay? So a conceptual model is about planning out in a diagram format what our database is going to look like and capture, okay? It doesn't tell you how it's implemented, it just tells you what you're capturing, okay? So you get a complete picture. We do a bit of that in this course. There's two ways of doing it. There's the old ER diagrams. Do you use ER diagrams? No, okay. We use UML these days, and that's what I'll stick to. You also do UML in system analysis and design, I think, okay? I'm not too picky about UML diagrams, okay? So some of the things we do in this class, I'll be lax with, and they might be strict on you in the other classes, okay? I'm just happy if I can read it and it makes sense and it's to a reasonable standard, like one of the many standards that's around, okay, then we'll be happy in this class. Some other classes you might get picked on for certain things, okay? So I'm a little bit open on that. So we have our conceptual model, which is just a diagram of what we intend to capture. Okay, well, this is kind of old school. Then we used to convert it into what they call logical schemas, where you type out what each table actually has in terms of the columns in the table. Okay, most of that's automated these days, which is what your first assignment's going to be. Okay, there's not much point in writing them out anymore. It's still an option in the exam if you want it. Okay, there's a lot of typing to do if you write the logical schemas. And then once we have those logical schemas, because diagrams are open to interpretation, right? So we need these written layouts of the tables to work out what the final structure is, okay? And that's the middle phase. Once we have that layout, we then go and write some queries and pump our tables into the database. We start them from scratch, okay? And that's the physical implementation. So here's an example, just to show you just how much these diagrams differ, okay? These two diagrams of a database, neither are the same. Okay, we have the diagram on the left. Each class represents a table in our database, so like a spreadsheet in our Excel workbook or something like that. They're all tables. Okay, there's a user affiliation, user phone number, user screen name, and users table. There's 4 tables there, and each one has a bunch of columns in them with their names. Notice the naming conventions aren't even standard. Okay, the only thing I ask of you guys this semester is that if you use a naming convention, it's consistent through all your tables. Okay, I don't care if you use underscores or whatever, it just has to be consistent. As programmers, should you guys have spaces in the names of things? No. Okay, so if you want a space, use an underscore. Otherwise, I suggest you use a camel case, which is start off with lowercase and every word thereafter has an uppercase. Okay. I also recommend that you name tables with uppercase, so title case, and use an S on the end as well. Okay, that's debatable. Some people say you should have tables with the plural name, and others say singular. Doug says he doesn't care. Okay, just as long as you use the same one. So this one here, so there's a conceptual diagram there: employee, project, and manager. This one has not that many columns, which is good, and this person's even included the data type on the columns. Okay, they've even told us here's the structure of our database in this diagram. So it's actually a way detailed diagram compared to the other one, because I can actually tell from this how to implement the database and what data types they want to use. Taking that conceptual diagram, I can see we have an employee with a name and a date of birth, which is a string and a date. So strings are just characters of text. Okay. We have manager, which looks like it inherits from a employee, so inheritance, which you guys learn about in programming fundamentals. If I say a manager inherits properties from an employee, do you think there might be more columns in the manager table? Or do you think a manager might be related to an employee? Okay.
I'd say there's less.
There's less. It depends how we do it, right? Okay, you've got decisions to make. There could be less, there could be more. Okay. The line tells us that a manager is related to an employee, and depending on how we create the database, we might just link the manager back to the original employee, or we might copy the values, the 2 columns from the employee table and stick them in the manager as well. 2 choices, okay? How you choose depends on the type of data and the queries that you're going for, okay? Decisions there. When we're writing out table schemas, we pick on the tables that are easiest to work with. So employee, what does that look like if I was writing out the table schemas? I would say employee, we have a name and a birth date, and I'm just saying employee name, in this case, is a primary key, okay? What is a primary key? Does anyone know what a primary key is?
It's like an index.
An index, okay? There's one of them, okay? Every record has a unique primary key. That means when someone gives you that name, you can go to that table and look up and get one record back and one record only, okay? That's a primary key. If we look at the manager table, okay, debatable. Do we have name, birthday, and title, or do we just have, in this case, it could be just name and title. It depends on the decision. Okay, and these are just how we walk through and decide what's going into these tables. This is what we'll do, I think it's week 3 from memory. Okay, so it's writing out, so because the diagram can be interpreted in so many different ways, we actually write out, this is what that table has. So manager has name, birthday, and title. If I wanted to go a different way, I could say manager has name and title only, because I can go look up in the employee record and get their birth date if their value's there, okay? So that's a decision there. And now I've actually said in writing, this is exactly what I intend, okay? Annoying thing about UML is it's not always what you see is what you get, okay? Some of the relationships between the tables might be many to many, okay? So an employee can be associated with 0 or n records, so many projects, okay? And a project, if we go back the other way, can have 1 or many members, 1 to ... n, okay? That's a problem, because that means we need another table that tells us this employee with this name was working on that project with that name, okay? So we have a table in between, which our UML diagram doesn't even show, okay? So it's a little bit cryptic. We will go over that again, and that's why a lot of people used to use this process. It clamps down what your choices are. Modern tools these days do this anyway, okay? You just skip this whole step. Once we've done that, we write our physical design statements, so our table creation statements. Remember I said keywords now are going to be in blue, okay, straight out of Management Studio. This is the query I would stick into Management Studio on a new database that has no tables, and this create table statement does what it says. It creates a table in my database, and it's going to create a table called employee. and it's going to have 2 columns in that table. One's a name that can have up to 200 characters. Is that long enough for a name? There's a design decision to worry about, okay? How many of you guys know Stuart from Programming Fundamentals? Yeah? Ask him how many first names he has and what happens when he rings up the tax office, okay? Their system rejects it every time. Be careful. So if you want to name, if you just want to have name, then you've got to remember that you might have first, middle and last name, and so you have to reserve enough characters for all of those, okay? So 200 is probably fair. Could be longer. What happens if I put in a name that's more than 200 characters? Sorry? Yeah, well, does it get truncated or does it get rejected? 50-50, okay? Most of the time it gets rejected rather than truncated, okay? Depends on the system, I guess. You might be able to control that. Birth date, there's a decision for you, okay? So birth date's fine, we're storing as a date. But what happens if I'm doing an audit log and I wanted to record the date a record was created? Date is probably not good enough. I would want a date time, okay? Because as long as we store the data, then we can get information from that data later on. So this record was recorded on that date at that time, and Eddie's come and edited it 5 minutes later, okay? But if you don't record the time on there, then you can't go back and check that. Yeah. Yep, you can do date stamps automatically, okay? But you still have to reserve that field as well. We will get to that one. So there's another keyword called default, and that will put in a default value for the date. And then you don't even have to worry about it, okay? If you don't put it there, it's not there to use later, and you can't invent it later on, okay? I recommend if you guys are doing databases for clients, always record the date a record was created and last edited, because quite often they'll do something stupid, the record goes missing and they'll blame you. And as long as you've time-stamped everything, you can find out who did it and when, and then point the finger if you really want. It's quite important, okay? So there's 3 tables out of our 4 from our previous diagram. So create table employee, we're creating a table for that employee that has a name and a date of birth. And interesting things down the bottom says constraint employee PK is a primary key, so it's setting up a column that's a primary key. That column already exists in the table, it's the name column, okay? So we can actually say certain things about the columns we've made. They can be unique, so like a primary key, so we can go look it up. We can put constraints like saying that the date of birth has to be within the last 50 years, all those sorts of things, they're constraints. And we write them in these table creation statements. These are what we put into Management Studio, which then throws them off to the database management system that then parses them, executes them against the database, and does all the work. Okay, we don't even need to know how it does it. Okay. Now the terminology, and I don't even use this terminology that often, but you will read about it, okay? Because we're using Microsoft, they seem to vary their terminology. In a relational database, a table is called a relation. You just have to get used to that. I'll be calling it a table, okay? We have attributes. Attributes are columns. They're just columns in your table, so an Excel spreadsheet, each column is an attribute. Okay, those attributes have to have unique names, so be careful about that. And we have tuples or tuples, depending on who you talk to, and they're just rows of data, okay? I'll be honest, I'll talk about attributes, rows and columns probably. That's about my terminology, okay? I hate these conventions that people use, but you will read about them. Okay, what makes a table a relation? Okay, there is technically a difference between a table in an Excel spreadsheet and a relation in a database. And the difference is that technically a relation should have a primary key and every record in that table should be unique. Okay, no duplicates. That's the main difference. Okay, a table is not a relation if it has duplicate records, technically, and no primary key. Okay, every row must be unique, and by having a primary key that's always different for every record, that guarantees it. Okay, it's pretty plain and simple. The primary key allows us to pinpoint just one record out of all of the records in that one table. That's the whole point of it. Okay, a relation is a real world or theoretical object. Okay, we already said it can be one or the other. Okay, it can be a person, it can be something about a person, all those sorts of things. Okay, an attribute is something about that person, if we're talking about people. So It might be their eye colour, their age, their date of birth, depending on which you record. Okay? In a table or a relation, those attributes have to have unique names. Okay? You cannot have two columns with the same name, because if you want to go pick out a person's eye colour, you need to know which column you're talking about. Okay? So specific. It won't even let you put two columns with the same name. Okay? It's not like Excel where you can do what you want. It has restrictions. Okay, we have domains. There's another word I'll never use again. Okay, domains are kind of like data types with restrictions. Okay, a data type, so whether it's an integer, and we do have big and small int and all that sort of stuff. Okay, but I just call it int. Okay, we have varchar and char instead of strings. Okay, so varchar is just a varying number of characters in a string, and you can say, okay, I don't know how big my string is, so I'll say up to varchar 200. So it will reserve enough space for up to 200 characters, or if there are only 50 are used, then it will use enough for 50 plus whatever it needs to do the calculation. Okay, if you do char, then it will reserve the 200 characters whether you use them or not. Okay, SQL Server has this wonderful thing where it actually pads it out with white space. Okay, it's a real prick. It'll burn you. Okay, I did that in a web prac one semester and everything broke because the drop-down list went to find an exact match and it was padded out with white space and it just spat the dummy. Okay, traditional Microsoft style crash. Bang. So be careful about that. So it's not just a data type, but it's the range of data that it can handle as well. Okay, decimals. It was great the first time I wrote this course. I always go decimal 3,2. That's 3 before the comma, 3 before the decimal point and 2 decimal points after, and it's not. Okay, 3 is the maximum number of integers in your number. So 3,2 would be 1 with 2 decimal places. So the largest number would be 9.99. Okay, 5,2. Okay, 2 of those numbers are decimal places, and the other 3 are for numbers. Okay, be careful about that. So 5,2. The largest number is 999.99. 3,2 is 9.99. Okay, be careful. It's a real gotcha on that one. The other thing, it happens at work all the time. Space is cheap these days, okay, or relatively cheap. Reserve enough space. We got into a fight ages ago about account numbers, okay. I wanted to make it like 25 because I like having just standard lengths, okay. I like varchar 25, varchar 50, varchar 100, 200, 500, easy, okay? If you do that, you never have to go look them up every time. My friend did something, I think it was varchar 10. The government changed their accounting format. Yeah, and the account numbers went to 19 digits. And I think it was a month before we fixed all the problems. Okay, if we just reserved enough space in the first place, like all our store procedures and things that we wrote would have just worked, okay? So think of the future, reserve enough space, even if you don't use it, because space is cheap in this, it's cheap enough for us not to worry about, okay? It's unlikely you'll be dealing with terabytes in the short term, okay, easily. The schema consists of the table name and those attributes in the table, so the column names, okay? And in a database, you'll find that the schemas have to be unique. No two tables can have the same name, and that's pretty much it. Tuples, as I said, tuples. There's one of the videos, the lady says tuples all the time. Okay, they're just rows of data in your table. And the thing about a relational database is the order of attributes, or the order of columns, and the order of rows in the table make no difference. Okay, that's what indexes are for. It can find things and pull them out wherever they are. Okay? The primary key means every row is unique, so it doesn't matter where it is, if it's at the start or at the end of the table, it'll find it in there and pull it out for you. Okay? So in a relation, the order is not important because the queries that we write will pull out the data in the order that you want and or in the interest that you want as well. Okay? So unordered is important. Keys. Okay? Keys, these are the really annoying thing. Keys are just ways of uniquely identifying something, okay? So a primary key is the one key that we chose to access all the records in that table as a primary point of choice, okay? Primary key is the one we go to first. But there's more than just one key. You can have as many as you want, okay? Every other key, if you want to implement more than one primary key, you can't, okay? Every table has one primary key. If you want other values that are unique, then you call them unique keys in a database, okay? You can have more than one unique value, but you have to implement them using, well, an index or something like that. They call them unique keys. Okay, keys have these sub-names. I've changed a few of these. A candidate key. So when you create your diagrams, you might go, well, first name, last name, and date of birth is a good candidate key. A candidate key is just a list of keys that you might choose for the primary key, okay? You're designing your database, you go first name, last name, date of birth and address, that might be a good candidate key. You might have a student number, that's another candidate key. And then you go, well, do I really want to look at 4 values or just use 1 value as the primary key? And then you go, well, scrap the student name, first name, what it is, and dates and stuff, and you go for the student number instead, okay? They're both candidate keys, but one of them gets chosen as the primary key, okay? So the primary key is just the one candidate key that you choose to implement on the database as the point of looking up a specific record. That's the whole point there. We have other keys called natural keys. Natural keys are still candidate keys, okay? A natural key, as an example, was first name, last name, date of birth, and address, okay? All those things are bits of data that we recorded about a student, and if we can guarantee that it's unique for every student, then that's a natural key, okay? But that natural key is made of 4 things, so it's probably not that easy to work with, okay? But it's still a key. Do we implement it? That's a decision you have to make. If you implement keys and they ever get a duplicate, it actually rejects the record, okay? So you've got to be careful about what keys you choose. So to put this into a context, here's my dodgy Excel spreadsheet, okay? We have our student table, or our student relation, I should say, okay, right, in a textbook. Okay, we have the relation name, the table, well, the attributes in that relation, so the different names in that relation. We have the table schema, which has the name of the table plus all the attributes that belong to it. What else do we have? We have an instance, which is all the data in that table, so all the rows. I never use that terminology again. A tuple, which we said is one row in that table, and we can look that up using a primary key. And there's our conceptual equivalent. Okay, so we've got our physical, our logical, and then our conceptual version of all of that. I hope everyone's happy with that. Okay, so there's what's in the database, and there's what our diagram looked like to begin with when we first drew it. Something like that. Our logical diagram would be down the bottom, just writing it out like that. Okay, so student has a student ID, email, and student name. And it's just working off that way. So there's the terminology that I hate so much. Okay, tables, rows, columns, I'm happy with that. Data types, I don't think anyone ever uses the word domain, okay? Maybe in a textbook. Primary keys, we said, are a point of looking up a specific record. Sometimes I'll underline them, so that if you see an underline under a column, it means that's the primary key, okay? That means every value in that column must be unique, must not be duplicated at all, ever, okay? Otherwise, we can't look up exactly one record. Sometimes a primary key might be a composite key. A natural key is a composite key if it's first name, last name, date of birth. Okay, that's a composite key because it's more than one attribute. So in this case, we have course and student as a composite key. That means we have to look at both those columns and make sure both values together are always unique for every row. Okay, that's common. I can tell you right now, if you have a primary key that's composed of more than 2 values, I'd go for what they call a surrogate key, okay, which is just a number, a random number down the column, 1 to 100, 1 million, whatever it is. Do you use surrogate keys at work? Yeah, preferred choice. Most programs these days, it doesn't matter what table you do, one of the programs we use will automatically put in a surrogate key, okay? Way easier to work with. Foreign keys. Okay, this slide's actually wrong. Foreign keys are attributes whose values are the primary key of another table. That's not true. Yeah, it just has to be back to a key that's been implemented in another table. So if you've got that in your slides there, I think I make this correction every semester. That's not very smart, is it? Okay, so unique key. And what's a unique key? Does anyone remember, or have we forgotten already? Okay. doesn't matter. Okay, a unique key is just one key that we've already implemented in the database. It has to be implemented, otherwise a foreign key won't work. Okay, so the database has to make sure that those records have a unique value for those columns, and then we can go and reference them from another table, and that's cool. Okay, it doesn't matter whether it's a primary key or a unique key, which is one of the other candidate keys. It just has to be unique. Okay, one or the other.
So in that example, that column of first name may not necessarily be unique.
That's
You
right.
always have two jobs.
Yeah. Okay, so choice is really important in this.
Usually use for if you like an access, if you were doing a lookup drop-down combo box or something in the UI, and use a foreign key in the table to look up those values.
Yeah. Yeah. So it's just a lookup, a V lookup in a spreadsheet. So you grab a value from one table, and it should point to exactly one record in another table, and it should only ever look up one record. Okay. If it comes back with two, well, that's impossible in a relational database because that's how it works. Okay. It means you haven't implemented the keys, which means you can't even create the foreign key in the first place. It won't let you do it. Okay. It'll have a whinge. So here we have an example. We have our student table, our course table, and then our enrolments. Okay. And in our enrolments table, we just have the student numbers, the course number, and the mark that the student got for the course. From those numbers, I can look at the student number and go back to the student table, find the corresponding unique or primary key, depending on what it is, look it up, and get the details for that student. So I know from this table that John Lee sat the course 1259, which is data modelling, and got 80%, which is a D. Okay? Is everyone cool with that? Foreign keys point back to mainly primary keys, but not always. Okay? I think every example we do this semester is, but there was one assignment last semester where I actually made it possible to do a unique key. Okay, why do we have foreign keys? Well, it's to make sure that we don't have orphan records that mean nothing to someone. Okay? If you have marks in the university system, those marks need to correspond to a course and to a student, otherwise they're pointless, right? If you've got pointless data in there, then that's space that's being consumed, and that space is probably more valuable than worrying about varchar 25 versus varchar 50. Okay, I guarantee it. So foreign keys are things that we implement in the database to make sure that records in one table definitely relate back to records in another, which is how we get that relational database name, because the records across tables are related to each other through foreign keys. Easy. Okay. It's a bit boring, isn't it? Okay. What else have we got here? So this one. Okay. And this goes back to what we're going to do next week and for your first assignment. There's more than one way to design a database. We've already mentioned that you can choose different data types and you can choose different data lengths. But some designs are going to be better than others. Okay. So here's an example, and this is what those officers in the state government love to do. They love their spreadsheets that have every column in the one sheet. Okay, they put everything into one sheet and then just manage all the records somehow. I don't know how it works. Okay, so here we... Sorry? Yeah, 6 years sorting it out. Okay, so here I have customer shopping habits. Okay, as one huge spreadsheet. This is my example from the other year. Can anyone see some issues with my spreadsheet? Sorry? What issues can you spot in my spreadsheet straight away? Multiple account numbers for the same person. So we've got 1101 for Mary Jane, and it keeps appearing multiple times. Okay. James bought the same thing from two different stores. Yeah. Okay. There's a few mistakes in there, and you know what happens if I put my account number in there and it's missing one digit, and we have to go update all the times it appears in there as well. Okay, so you guys have already spotted it. There's redundancy for sure. Okay, so Mary Jane's in there 3 times, same thing 3 times. Her account number, her name, her address, everything. Okay, that's duplication you worry about, not the varchar 25 versus 50. That's the duplication you want to get rid of. Okay, we have an update anomaly. Okay, this is me with my missing 0. Really smart. okay? Hardly Norma. That's suddenly a new record, right? That's nothing else there matches. So that's a new entry that doesn't match anything else. When we're doing a search, it doesn't match other things, okay? So is it the same? Is it different? I have no idea. Database systems aren't great at determining that, so that needs visual inspection to check it out. Deletion anomaly, okay? Let's say Bob bought this coffee maker. It was dodgy. He brought it back. He goes, no, I don't want another one. Do we delete his record and lose the fact that we have an account with Bob? Or do we just remove the coffee machine there, which means there's a half-empty entry in that database, okay? So there's a problem there. There's a deletion anomaly. If we brings that coffee machine back, we lose all the information about Bob in that table. That's not so good. Okay, so you might read a few things about this. Redundancy. Tables should be designed to minimise the number of duplicate records, okay? We can put duplicates in them as long as they have different primary keys, okay? But we don't want that. Duplicates are wasted space, which is more space consumed than varchar 50 or something like that, okay? We have update anomalies, insertion anomalies. So every time Mary comes back to the store, we have to enter her account number, her name, her address, and what she bought. And if she's like me, she might get that account number wrong, which suddenly is a different Mary, okay? And then you have the deletion anomalies where you might want to remove something, but you lose information as a result of that as well, okay? We want to keep Bob in there because we know he's an unsatisfied customer. Next time he comes back, we want to treat him really well, but if we deleted his record with the coffee maker, then tough to you, okay? So, a better design. When we talk about our design, we're saying look at the table and look for things that are related, okay? So what's important about a customer? A customer has an account, a name, an address. That's everything about a customer you need to know, right? Okay? So that is a definition of a single entity in our database. I like calling it an object, but technically it's not, okay? An object is one entry, but still. Okay, I'll call them objects, but that's bad, I guess, okay? So one entity is a customer. Another entity is customer purchases. They're two different things, so they should be in two different tables, okay? And then we use a foreign key to tell us who the purchase was for, okay? So now we have an account number, which is a unique identifier, and I can go 1101 was Mary Jane. She bought a coffee maker from Hardly Normal, okay? Don't ask me why, I just did that. Okay. Why do we want to do that? Because it avoids redundancies. So I only have to have Mary's name in one table once, and then wherever Mary goes, I just create a link to the other records. That's it. Okay? So avoiding redundancy, which means I only have to type it in once, and then I look up the value when I need to use it. Okay? Really important on that one. Okay? And that's what we call normalization, which I think we do in week 7. Okay? There's a few more examples here. So this one, we have students, courses and rooms. And I'll grab this one off the website somewhere. If every course is only in one room, then it contains redundant information, okay? Do we really need to store the room with the course every time? Not really. Might as well just separate it out into one table and refer to the course, something like that. Okay, if we update the room for just one of those people, what about the others? Is one person in one room waiting for the same course as 50 in another? It does happen. Okay, it's a bad choice. What happens if we delete something? Okay, so suppose everyone drops the course. Okay, it does happen. It happens at this uni, right? Sometimes we have to close the class. Everyone has to escape the class and then re-enroll in another one. Okay, but we don't necessarily want to lose that class information, right? So we make sure it's in a different table. Okay? Sometimes they close the class and then reopen it 2 weeks later when the other classes are full. Okay? But if you delete it, you can't do that. And then the other thing is we may not be able to create a room reservation without students. Okay? So there's a whole bunch of things. So insert, update, delete anomalies, depends on what's going on. Okay. So I'll skip through that because we've got an example here. Okay, so here's a rip out of a spreadsheet. Okay, this is what you get from your clients. I have students and courses, and when we want to pull data from a spreadsheet and put it into a database, we have to make sure it matches that structured shape that we talked about earlier. Okay? The first thing about databases is we know that a record relates to other records, which means a record should be about one thing and one thing only. And here we have a student, Mary, who has 2 courses. Okay? They're 2 different things. So this table is what we say is not in first normal form because it doesn't work in a relational database, because if I want to go look up what the course is, I have to do some sort of fancy calculation based on that string in there with the two values. Okay? Do I do a split on the comma and read the value after the comma before it, and how do I attach that to another table? It's really hard. Okay? So that's not in first normal form. And if we want to put that in a relational database, we actually have to break it apart and create a new entry for each one of those records. Okay? So Mary has 2 courses, and that means Mary's records should be on 2 rows. Okay? Simple as that. Every column should have exactly 1 value per row in a relational database. This one here is still not in first normal form. Okay? Because now we have 2 courses for Mary. What happens if she takes a third? I have to change the structure of the database by adding a new column, a new attribute, which means I have to write not a table creation statement because it's already created. I have to do an alter table statement, and I can tell you right now I don't know how to do that off the top of my head because I never do it. Okay? You should be getting this stuff correct first. So if you have repeating columns, that's not a good design. Okay? Same deal. If she's got 3 courses, 4 courses, you have to keep modifying that structure that doesn't like to be modified just to add those bits of information in. It also means that what happens if Mary takes 6 courses and the average student takes only 2, then you're going to have 6 columns, and for most people, 4 of them are going to be empty. Okay? Again, that's a waste of space. So same deal. It's actually the same process. You pull it apart, put it on different rows. Okay? You can see that what would be the primary key of that table, that new table there. How do we uniquely identify each row in that table? Can't be course because CS145 appears twice for 2 different people. Student and course together, okay? Sorry? Yeah, well, the candidate key or the primary key, they're going to be the same on this one. It's going to be both the columns together, okay? And for every new course that Mary takes, as long as it's not the same as one of her existing ones, it can go into that table, which means she can take 200 if she wants to be that crazy, okay? This one here. So let's have a look at this one. How many different things are being recorded in this table? My dodgy Excel spreadsheet. What unique objects can we see in there? Postcodes, you're like me, okay. Sorry?
Rooms.
Something about rooms, okay. So rooms probably relate to courses. There's students, okay. Students are one thing, we know that for sure. Courses are another thing. Marks relate to courses and students, so that's a separate thing again as well. Okay, there's at least 3 different things in that one table. So they're the things we need to identify and pull apart, okay. And this is what we do in normalization. So students do not relate to courses, okay, except through a mark, okay. So a student in a course gets a mark, that's one thing. A student by themselves is another, and a course by itself is another, because they can all coexist without each other, okay. It's really odd. So let's have a look at this. So let's pick it apart. We can say students have a suburb and a postcode. We can say enrolments are based on students' courses and have a mark. And then we can also say, well, that's what you... Sorry?
I was going to say suburbs relate to a postcode.
Yeah, no, I do that too, but it's really bad, okay? That's why I put this example up here. I always jump to these conclusions, and it's where it's bad depending on the data, okay? In America it works, but not here. Suburbs and postcodes cannot be separated in Australia, okay? We'll get to that one. I did that demo once. And I looked at it and I go, oops, that's not right, okay? It depends on the data. So when you're looking at data, you've got to make sure you look at the whole picture and not just a few records, okay? So we know that students are one thing, so we can pull out everything about a student and stick it into a separate table, which means those students are going to appear once and once only. And whatever the primary key is, well, it's probably name in this case, okay? I haven't got a proper... What would be a good primary key for a student? Student ID would be better, okay? It's just missing on the diagram. Okay, so a student as an entity is acknowledged by the student name, the postcode and the suburb, and that tells us everything about the student. They're all related, so we stick them in one table. And that means Mary appears once, Jeff appears once, Jane appears once, and it's all in that one table, okay? Everything else in other tables relating to Jane or whatever it is, come back to that one table. Okay, so that's a good example there. So now that I've pulled out information about the student, I still have the student enrolment table information left over. Okay, so we've got our student name, the course name, the room, and the mark. Can anyone see the next thing that might be appropriate to pull out? Course. Okay, courses have nothing to do with students other than the mark that they might get for it. Okay, so we can pull a course out, and that's what we end up with. Okay, we end up with a course table that has the courses represented once and once only. So what the course is, what the course name is, and where it was hosted. And then we have the enrolments, which have the name and the course of the person in that, the number of the course, or whatever it is, and the mark that that person got for that course. Okay, so there's no duplicates at this anymore at all. That means if I go and update one thing, I update one thing only. Okay, and I don't have to worry about missing anything else. If I go to Mary's record in the student table to update her address, it doesn't impact on her enrolment or her courses or anything like that. It's safe. Okay, the suburbs. So there's our normalised tables, so you guys can have a look at that. As I said, we will go through this again. This one here, so postcode and suburb. Can we separate those? So I fixed up the data so we couldn't separate it, right? I had to go look it up. There are anomalies in the Australian system where you cannot separate suburbs and postcodes because some postcodes are across 2 suburbs and some suburbs are across 2 postcodes. And so if you pull out Modbury, you don't know if Modbury is if you pull out 5092, you don't know if that refers to Modbury or Modbury North. If you pull out Adelaide, you don't know if Adelaide is for the postcode 5000 or 5001, okay? Because it's not unique, you can't actually separate it out. The moment you do, you know they're from Adelaide, but you don't know what their postcode is because you'll get 2 records coming back, okay? You look up Adelaide, so what is it? Mary's from Adelaide. If you separate out the postcodes, then you'll get 5000 and 5001 coming back, but you don't know which one Mary was, okay? If you pull out the suburbs and you look up Modbury, well, that kind of works. But if you look up 5092, you'll get 2 records coming back saying Modbury and Modbury North. Which one were they? You don't know, okay? So when you do talk about foreign keys and normalisation, foreign keys always have to point back to one thing and one thing only. And the way that we do that is making sure that the primary key is unique for every row. And in this case, we can't have a table of suburbs or postcodes because some suburbs appear twice with 2 different postcodes, and some postcodes appear twice with different suburbs. Okay, it's just the way it is. Bit of a killer. It's murder, trust me. Okay, I'll leave that alone. Okay, so that's the overview for this semester. I think normalisation is the worst thing. Okay, it always is, but we will come back to it in week 6 when you guys are all through the query stuff. Whole point of this semester is to learn how to build a database. So looking at, well, often you'll get given data from someone else, okay? That's going to be the main thing that's going to happen. You need to look at that data, look at the titles and say, okay, what are the real things that this data is about, okay? Are students, courses, students in courses separate things, okay? And then that's what you need to look for. Okay, so are there any real-world or theoretical objects? Okay. What you do when you've got that is you determine what attributes are relevant to those objects because they're the attributes that make the columns in your tables. Okay, so if you've got existing data, that's dead easy, but if you're building a database from scratch, you have to come up with those attributes. Okay, you need to determine what data types you want for those attributes as well. That's a little bit of a killer. You need to check and make sure that those attributes relate back to that object only. Okay, a student suburb, an address is for the student, but is a course ID for a student? Probably not, okay? Unless it's for a student enrolment, it's got nothing to do with it, okay? And then the last thing that you do, once you've got all that sorted out, you can check the data, or the best way of doing it is actually to ask the client and say, what are the unique entries in this data, okay? And again, you get burnt on that as well. I'll tell you right now, I had a system where I wrote what they have work orders, okay? They had work order numbers, and they said work order numbers were unique. It was unique until they joined the southern and the northern and the something else group, and then we found out that their work order numbers started with N for 2 different groups and stuff like that. Okay, so whenever a client tells you something that's unique and you're not sure, what type of key should you add to a table automatically? Okay, I thought work order numbers were unique. They weren't, and it bit me. Okay, what column could I have added to a table to make sure every row was unique so that wouldn't have mattered? Sorry? An ID, okay? A surrogate key ID, just a number from 1 to infinity, would have saved me. Then when the non-unique records came in, I still had that one unique value to look up and differentiate, okay? So we'll leave it at that. I'll see you guys next week, and I think we'll start doing some more interesting stuff.